In this question, we are trying to find the domains of the following functions. The first function is f of x is equal to the cube root of 2x plus 8. So a few reminders first about vocabulary. Remember that this 3 is called the index. That's why we say this is a cube root. And what you have inside of the radical, the fancy name for that quantity is called the radicand. So when we're asked to find the domain of the function, we're looking for all of the possible input values, which means the x values in this case. What are the values that x is allowed to be? And when you have a cube root, what you need to remember is that it is okay to take the cube root of a negative number. It is okay to take the cube root of 0. And it's also okay to take the cube root of a positive number. So I've made up a few values here and just want to remind you why this is okay. Look at the first one. If we're taking the cube root of negative 8, then we're looking for a number that I can multiply by itself 3 times that will equal negative 8. So in this case, that would be negative 2. Negative 2 times negative 2 times negative 2 gives us negative 8. So therefore, the cube root of negative 8 is equal to negative 2. Done. The second one, the cube root of 0, would just equal 0. And again, that's because 0 times 0 times 0 is indeed 0. So it is okay to have 0 inside of a cube root. And then the very last one, the cube root of 8, we're looking for what number we can multiply by itself 3 times. That will give us 8. And in that case, it's going to be 2 times 2 times 2. So that means that the cube root of 8 is equal to 2. So my point in showing you these specific values is for you to see that there are no restrictions for the numbers that we can have inside of a cube root. That means that the domain for a cube root function will be all real numbers. So the domain of function f, sometimes people write that like this with a capital D for domain and a little f as a subscript. We can say the domain would be all real numbers, which would be from negative infinity to positive infinity if we're writing our answer in interval notation. So there are no restrictions. However, if we look at function g of x is the fourth root of 2x minus 4. So this time the index is a 4. So we have to think about the types of numbers that we are allowed to have inside of a fourth root. So again, just as an example to get you to think about this, if I were to ask you for the fourth root of 16, let's say, that means we're looking for a value, a number that I can multiply by itself 4 times that will give me 16. So in this case, 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 would equal 2. So it is okay to have positive numbers inside of a fourth root. However, notice what happens if we're trying to take the fourth root of negative 16. Is there a number that we can multiply by itself 4 times that will give us negative 16? And in this case, there isn't a value, there's no real number that will make this work. So this tells us that we cannot take the fourth root of a negative number. And in fact, that is going to be true for any even index. This could be the square root of 2x minus 4 or the sixth root of 2x minus 4. We cannot end up with a negative inside. So that means that this quantity, remember, that's called the radicand, that quantity needs to be greater than or equal to 0. It cannot be negative. It can be 0 or it can be any positive number, but no negatives. So therefore, to finish this domain, we'll need to take 2x minus 4, that's what's inside of the radical, and set that greater than or equal to 0 and then solve. So we'll add 4 to both sides, which will give us 2x is greater than or equal to 4, and then divide by 2, which leaves us with x values must be greater than or equal to 2. Now, the problem asks you to write this in interval notation. So if we think about what this looks like on a number line, if I want the x values to be greater than or equal to 2, and I'm going to choose values that are to the right of 2. And then I said it could also be equal to 2. So you can either do a solid dot, or if your instructor has you use brackets and parentheses, that would be a bracket from 2 to infinity. So this in interval notation would be a bracket. 2 to infinity would be the interval, which represents the domain of function g. Any value from 2 to infinity will work for x and will end up giving us a positive number or 0 inside of the radical.